Hey everyone, welcome to Code Hustlers, where we decode challenges and optimize impact. So in today's video, we will dive into an exciting problem of LeetCode 141 known as linked list cycle detection. So if you're preparing for a coding interview now, this is a must-know topic. So let's get started. To solve this, we will need a cyclic algorithm known as Floyd, Tortoise and Hare. In case if you don't know what cyclic linked list is, you can refer to the previous video where I explained what cyclic linked list is and the brute force efforts for solving this question. So the link is in the description. So in this question, we will be using a two-pointer technique. Let's see how this algorithm works. So we will use two pointers, slow pointer, which moves one step at a time, and a fast pointer, which moves two steps at a time. So we will traverse the linked list in such a way that while the fast pointer does not equals to none, or the fast next pointer does not equals to none. So you will think why we are using this fast pointer and a slow pointer. So I will be talking about the intuition further in this video. So we can visualize this for a normal linked list in such a way that so we can see that the slow pointer now moves to 2 and the fast pointer have moved by 2 steps and moved to 3. In the next turn, the slow pointer have moved to 3 and the fast pointer have moved to 5. So we can see that while the fast pointer's next pointer has become none, so we will see that it will get out of the loop actually. So thus, if the next pointer reaches the end of the linked list, it is a normal linked list. So we return false. So we have to keep in mind that a normal linked list always has a null pointer, but a cyclic linked list, as it is cyclic, doesn't has a null pointer. So as the fast pointer reaches the end of the linked list, so we have written false. But what if it's not a normal linked list? So in this case, the algorithm remains the same. We use the two pointers, slow pointer and the fast pointer, where the slow pointer moves by one step and the fast pointer moves by two steps. So we can see that both the pointers are moving same as we see in the last example. So now we see that in the second step, we see that both the pointers have trapped in a cyclic loop. What I mean by trapped in a cyclic loop? So we can see that when this pointer moves to 9, they can't go to 2 as the 9 is pointing to 3 and it will go on traversing in a loop. So we can see that the distance between the two pointers, that is the distance between the fast pointer and the slow pointer. I'm not talking about the distance between the slow pointer and the fast pointer. The distance between the fast pointer and the slow pointer is 5. And in the next turn, we can see that the distance has decreased by 1. That is now the distance has become 4. Why? So we have to understand that the fast pointer is moving by 2 steps towards the slow pointer and the slow pointer is moving away from the fast pointer by 1 step. So we can see that we can take the moving away from the fast pointer as negative and moving towards the slow pointer as positive. When we calculate that, the resultant will give positive 1. That is, the distance is decreased by 1 instead of increasing as the slow pointer is moving slow. That's why we named it as a slow pointer. And fast pointer is moving by 2. So we can in the next step see that this distance is decreased to 3 and in the next step the distance is decreased to 2. In the second last step, we have seen that the distance is decreased to 1. And finally, both the pointers are meeting at a node that is 8. So we can say that the cycle exists in the linked list. So talking about the intuition, the first question which arises is why? Why should we use this? And why the algorithm is working? So we can see that in starting, the distance was 5, then distance was 4, then distance decreases to 3, then distance decreases to 2, and distance decreases to 1, and distance decreases to 0. The main reason behind this is, as I told you, the fast pointer moves by 2 steps towards the slow pointer and the slow pointer is moving one step away from the fast pointer. So at the end of the day, the distance is decreasing by 1. So we can say that the distance, no matter what, is divisible by 1. So at the end of the traversal, the both pointers are going to meet at a node, and we are going to return true. What I mean by true? That the distance has become 0 and a cycle exists in the linked list. So talking about the space complexity and all, the space complexity is linear because we are just using two pointers, that is slow pointer and the fast pointer. We are not using any set or any other data structure to store the nodes and all. Talking about the time complexity, it is approximately equivalent to big O of n. Why did I use the term approximately equivalent to big O of n? Because it is possible that it may take 2 to 3 turns to meet at the point where we can return true. But it is also possible that before traversing the whole linked list, the both pointers collide at a point. So definitely it can be a half n or 2n or 3n, big of 3n, big of 2n, big of half n. Definitely depends on the linked list. But we have to consider big of n. So that's how you can detect a cycle in a linked list using Floyd, Tortoise, Hare algorithm. If you find this video helpful, you can give it a thumbs up and please consider subscribing us.